So here we are again. So we'll talk about the Centipede node and the instructions and the distance calculator here. So Centipede node, as we can see, here's a constructor. There's no default constructor just simply because every time we construct a Centipede node, we should have a head and other nodes attached. So as I was saying before, this is a recursive function. We take in the number of nodes left in the Centipede, and then if nodes minus 1 is equal to 0, or is greater than 0, so if there's a node behind this one, it calls a constructor for the next node down. So it's kind of like a single linked list this way, or I guess a double linked list. And if not, then next is equal to 0. We call it init. Update. Okay, so the update for Centipede node doesn't have to do any of the calculations that the first Centipede, or the Centipede head has to do. So if we're not changing heads and we're active, then we go into this. If distance less than 0, we get the next instruction. If we're not turning, we'll move sideways. If we're turning, we'll move vertically, and then we'll set position of the sprite. So where the magic happens is here in the get next instruction. If we're changing, then, or if changing equals true, then we, well, we pretty much reset all the distances to be the very top one, or all the instructions to be the top instruction, because none of the other instructions matter. So if we're not changing and we have a top, so if there are actually instructions on the stack, then we delete the top instruction, and then the new top is set to be all the values. If the direction is 0 in the instruction, then turning is true. If the direction is not equal to 0, turning's false, and we do a little bit of a clamp on the, well, like a custom clamp on the Y, which is just getting to the cell, the nearest cell area. So here we add instructions. So this is called from the head or the previous Centipede node. We get the distance, the direction. So if we have a top already, then we stick this on the bottom of the stack, and then call add instructions to the next. Otherwise, we call, and we don't have to subtract any of the distances or anything because all the distance will be the exact same for the head. Adding the distance, sorry, my headset cut out again. It's all the exact same distance for the head that has to travel and the body parts. If we don't have the top of the stack, then that's when we're adding distance for each node. And we add 16 because that's the width of all of the sprites from position to position. So from middle of sprite to middle of sprite, it's 16. Set bottom equals top. If we're changing, then we get next instruction because we won't have an instruction on the stack, and we set change equal to false after the next instruction. Remove instruction. This is called, I'm trying to think of when this is called. I know this is called, I believe in the Centipede head when we're redoing things. When it's hit going vertically, I believe. So this gets rid of the instruction and then calls down to the next one to remove that to remove the top instruction, or to remove the last instruction that was just put in. So reposition. This sets the position of the sprite to be correct with the new head. This is called when the new head is made. And then clear instructions. This is also called when the new head is made. As I say right there. So we set changing to true. We get a couple of temps, and we walk through and deleting all of them. And then we set the initial values to 0, call the clear instructions on next. So now let's look at the instructions. So here we have the instructions file. As we can see, it's very, very, very simple. We have a default constructor, sets all the values equal to 0 except for direction, that sets it to 1. And then we have the constructor that's actually used that takes in the distance, the previous instruction, and the direction, and sets all the values for that. If we look at the .h, yeah. So now distances. So this is a singleton. We only have one of these, and pretty much all it has is the function getDistance. As I say here, solely designed to create the distance measurements and then feed them to the Centipede as needed. So in the default constructor, we are just creating the distance map. And the reason I put 30 cells here is because the play area is 30 cells wide. So the maximum amount of distance you can travel is 16 times 30. I know you had commented that earlier in the sprint. Well, that's why. And then getDistance. This takes in the amount of cells it's going to travel and returns that distance minus 1 cell, because this amount of cells is including the final cell that the mushroom is actually in. So it subtracts 1. So that concludes all of the Centipede stuff. I think I got everything. I will freeze this, and then in the next segment I'll talk about the rest of the AI.